looking at lesson 1-2, which is dealing with properties of real numbers. This is dealing with some of our different properties of addition and multiplication. It's dealing with the different types of numbers. So the first problems picked here were name the sets of numbers to which each number belongs. First one I picked was problem 21, which is the square root of a 121. Just because you see a square root does not automatically make it an irrational number. Check, see if it comes out nice on the calculator. When I plug it in, I get 11. 11 is a whole number, which your book will use a W for. It's also an integer, which they use a Z for, because it's a positive, negative number, no decimal, no fraction. It's going to be a rational number, because I can write it as a fraction, and that's what rational numbers can do, is be written as a fraction. And it's also going to be a real number. When I look at the problem 22 with the negative 4.55, students want to put it as an integer because it's the negative sign, but remember, integers can't have decimals or fractions. So when I look at it, I could still write this as a fraction, so it's going to be a rational number, so we use the Q again. And it's also going to be a real number. And then when we look at the square root of 10, I put that on my calculator, I get a decimal that keeps going, so that makes it irrational. They use the I for irrational. So you gotta be careful when you're using and identifying. Make sure you know that the I is irrational and not an integer. And it's also going to be a real. Now if you notice, all three of these, real fits in all three of them. And that's what we're going to be dealing with in all of these right now, this semester so far, is real numbers. Problem 32 and 33 that I picked asked us to name the properties illustrated by each equation. When you look at problem 32, notice that the parentheses are still grouped around the 2 plus 14. Doesn't matter if it's the left side of the equation or the right side. So because the grouping is still the same, this is going to make it the commutative property. Because we're adding, it's the commutative property of addition. Make sure you distinguish, don't just say commutative property, make sure you tell addition or multiplication. When you look at problem 33, 1 and 2/7 multiplied by 7/9, go back to your earlier math days, change that 1 and 2/7 to an improper fraction by taking the 1 times 7 and adding 2. I get 9/7 being multiplied by the 7/9, I get the 1, which makes it the multiplicative inverse. The next group of problems we're going to look at is asking us to identify the additive and multiplicative inverse. Additive inverse means I can add it together, the two numbers, and get a 0. Multiplicative inverse means I can multiply two numbers and get a 1. Make sure you distinguish between which is which. So we're going to start with the additive inverse. The additive inverse is just switching the sign. So I'm going to have 0.125. The multiplicative inverse is what number can I multiply so I get a 1. It's always going to have the same sign, so I'm going to have 1 over a negative 0.125. And now as advanced algebra students, we shouldn't have fractions and decimals mixed together, so you've got to convert this. Take 1 divided by the 0.125, don't lose the negative sign, you get a negative 8. When we look at problem 48, our number is a negative 4 3/5. Again, the additive inverse is just switching the signs. So I'm going to have a 4 3/5. The multiplicative, I have to use the reciprocal, just like we did on the previous one. Let's take that negative 4 3/5 and switch it to an improper fraction like we just did. 5 times 4 is 20. Plus 3 is 23, so it's 23/5. Don't lose the negative sign. So when I go into the multiplicative inverse, I have to use the reciprocal. I get a negative 5 23rds. Problem 49 and 55 here asks us to simplify each expression. In other words, collect all your like terms. So when I'm looking at it, I have a 7a and a negative 4a. So 7a minus 4a is 3a, I have a 3b and the negative 5b, which comes out to be a negative 2b. Problem 55, I have to use my distributive property. So what's on the outside has to go to everything on the inside. So 4 times 0.2 gives me a 0.8m. 4 times the 0.3n is a 1.2. Don't lose that minus sign in there. I have to take that negative 6 and distribute it. So the 6 times the 0.7, and you not losing that sign, is going to be a negative 4.2m. And then a negative times a negative is going to give me a positive. 6 times 0.5 gives me a 3m. Going in and collecting like terms now, I have a 0.8m and a negative 4.2m, which gives me a negative 3.4m. Then I have the negative 1.2n and the positive 3n, which if I put those two together, I'll have a 1.8m. So my final answer is a negative 3.4m plus a 1.8m. And the last example is a story problem. Now, it says if Andrea earns $6.50 an hour, illustrate the distributive property by writing 2 expressions representing Andrea's pay last week. And there's a little table off to the right of this problem if you have your book open and you're looking at page 16. Basically what we're looking at is we're looking at taking her pay and multiplying it by the hours each day. Sometimes for some of you, it'll help to write a note what you're doing. So that's why I wrote it up that way. Her pay is $6.50 an hour. On Tuesday, she works 4.5 hours. On Thursday, she works 4.25 hours. On Friday, it's 5.25. And Saturday is 6.5. And Sunday is 5 hours. There's one way of the 2 it asks. The second way will be actually going through and using the distributive property. Taking that 6.5 and multiplying by everything in for parentheses. So 6.5 times 4.5 plus 6.5 times the 4.25 plus 6.5 times 5.25 plus 6.5 times 6.5 plus the 6.5 times the 5. Now, when you look inside the parentheses, you have 1, 2, 3, 4, 5 expressions. When I do look at the Greek part of your simplified, I have 1, 2, 3, 4, 5 expressions.